Fine, guys, let's start. Okay, so we will see some of the functions, okay, and different concepts of linear algebra. But first of all, why? Okay, because there are so many topics in maths, right? We have calculus, we have linear algebra, we have normal algebra, we have trigonometry. Okay, there are so many. So I would say all of these somewhere or other particular place will be helpful. Okay, because calculus అనేది యూస్ఫుల్ అవుతుంది మనకి when you are learning the linear regression, right? First model is called linear regression మనకి machine learning model లో. Over there you will use the concepts of differentiation. Okay, basic, don't worry, but basic differentiation, right? And somewhere in the statistics లో మనకి integration touch అయింది. Anybody remember? ఇంటిగ్రేషన్ ఒక దగ్గర టచ్ అయింది, గుర్తుందా? ఐ థింక్ క్యూములేటివ్ ప్రాబిలిటీ దగ్గర, రైట్? సో ఓవర్ దేర్ ఓకే, క్యాల్కులస్ అనేది మనకు టచ్ అవుతుంది. అండ్ లీనియర్ ఆల్జీబ్రాలో మోస్ట్లీ మనం మ్యాట్రిక్స్ మీద చూస్తాం. ఎందుకంటే సి మీకు ఇప్పుడు ఇంకా మనం మిషన్ లెర్నింగ్ అనేది వి డి నాట్ స్టార్ట్ యెట్, బట్ సమ్ టైమ్ ఇన్ ఫ్యూచర్, ఓకే? సో ఇన్ ఎంఎల్ ఆర్ మోస్ట్లీ ఇన్ డిఎల్, okay, which is called as deep learning. Okay, so over there everything will be in the matrix multiplications only in the back end. Okay, మీరు particular గా చేయాల్సిన అవసరం ఉండదు ఇవి. Okay, most of the time 99.9% of the time, but you should have an understanding, okay, how it's working in the back end. Fine. So ఎలా అవుతుందంటే see, ultimately what is a model, guys? Just to give an overview, model అనేది any machine learning model. Okay, so in simple words, it's nothing but some numbers. Okay, then we will call it as metadata, guys. Okay, so from because sometime in the middle I will also speak about some practical words and practical scenarios. Okay, so మీరు ఇప్పుడు after the course, once you get the job, fine, so once you start training the models, you will store in some file. Okay, so model కి సంబంధించి ఒక ఫైల్ ఉంటుంది, దానికి వీల్ కాల్ ఇట్ as metadata. దాంట్లో ఏముంటుందంటే మోడల్ డీటెయిల్స్ ఉంటుంది, మోడల్ నేమ్. ఓకే, అండ్ మెయిన్లీ మోడల్ అనేది నథింగ్ బట్ సమ్ నంబర్స్ ఉంటాయి అంతే. వాట్ అల్టిమేట్లీ కంప్యూటర్ సిస్టమ్ అర్థమయ్యేది నంబర్స్. అగ్రీ? సో మోడల్ కదా, వెదర్ ఇట్ యూ టేక్ లీనియర్ రిగ్రెషన్, లాజిస్టిక్ రిగ్రెషన్, అల్టిమేట్లీ దెర్ విల్ బి సమ్ నంబర్స్. దీస్ ఆర్ కాల్డ్ as వెయిట్స్. ఓకే, సో వెయిట్స్, ఎవ్రీథింగ్ ఈజ్ అబౌట్ వెయిట్స్. ఓకే, మీరు ఏ మోడల్ తీసుకున్నా, డీప్ లెర్నింగ్ మోడల్ కానీ ఎవ్రీథింగ్, ఫైన్, ఇట్స్ నథింగ్ బట్ వెయిట్స్. ఓకే, మోడల్ అర్థం చేసుకునేది వెయిట్స్ అంటే ఈ పర్టికులర్ ఫీచర్ కి ఎంత వెయిట్ ఉంది, ఓకే, ఈ పర్టికులర్ ఫీచర్ కాంట్రిబ్యూషన్ ఎంత ప్రిడిక్షన్ లో. ఓకే, సో లైక్ దట్ డిఫరెంట్ కాన్సెప్ట్స్ ఉంటాయి. సో బట్ ఐఎమ్ జస్ట్ గివింగ్ ఎన్ ఓవర్ వ్యూ, ఐఎమ్ నాట్ గోయింగ్ ఇన్ టు డీటెయిల్స్. ఓకే, బట్ అల్టిమేట్లీ మోడల్ అనేది టెక్నికల్ గా మ్యాథమెటికల్ గా ఆలోచిస్తే ఇట్స్ నథింగ్ బట్ వెయిట్స్. ఓకే, బట్ అదే ట్రైనింగ్ పార్ట్ అనేది డిఫరెంట్. ఓకే, సో అది ఎలా వర్క్ చేస్తుంది, దాంట్లో ఉన్న మ్యాథమెటిక్స్ ఏంటి, మోడల్ ని బిల్డ్ చేయడం అనేది వన్ పార్ట్, right? So how you want to build a model is one part. Okay, and once you have built the model, actually what is a model? Model is nothing but technical or mathematically speaking, it's just a collection of weights. Okay, so ఈ వెయిట్స్ మీరు యాక్చువల్లీ తీసుకొని మీరు ఇన్పుట్ ఉంటుంది కదా, ఇఫ్ యూ పాస్ ఎనీ ఇన్పుట్, ఈ వెయిట్స్ తో మీరు మల్టిప్లై చేస్తే మీకు వచ్చేది అవుట్పుట్. మీరు ఇప్పుడు ఫర్ ఎగ్జాంపుల్ సిరి అండ్ మేఘనా, దే ఆల్రెడీ done some projects in the final year. I think Siri did diabetics prediction and Meghana did what, heart attack. Yeah, heart attack prediction, right? So dantlo they have generated some model. Fine, what is the purpose of model? After that, once you hand over this, okay, to someone, once they pass some input, it should give output. That is the whole purpose of any model. ఇది ఎలా జరుగుతుంది? మోడల్ ఈజ్ నథింగ్ బట్ కలెక్షన్ ఆఫ్ వెయిట్స్. ఓకే, వన్స్ యూ పాస్ ఇన్పుట్ కూడా వెయిట్సే కదా. ఇన్పుట్ ఏముంటుంది, ఇప్పుడు మనం చూసిన ఇన్పుట్స్ లో ఫర్ ఎగ్జాంపుల్ కార్ ఎగ్జాంపుల్స్ లో చూస్తే ఏముంది, మైలేజ్ ఇంత, నంబర్ ఆఫ్ వీల్స్ ఇంత, దీని ప్రెషర్ ఇంత, వెయిట్ ఇంత, డిస్ప్లేస్మెంట్, ఆల్ దీస్ ఆర్ జస్ట్ నంబర్స్. సో యూ టేక్ దిస్, ఆల్ దీస్ నంబర్స్ విల్ బి వన్ మ్యాట్రిక్స్. ఓకే, అండ్ మోడల్ అనేది ఇట్ విల్ బి అగైన్ whatever it has trained, okay, whatever it has understood, okay, each model that will also be in the form of numbers. Okay, now these became two matrices. Okay, now when you ask for model.predict, okay, these two matrix gets multiplied, and whatever the value you are going to get, okay, that will be the output. Okay, simple. Getting? So Miku, if I would like to show you. Recently, I was working on one data science project. Okay, Dantlo, what we did is I'll show you it, guys. Okay, we were training a e-commerce website anamata. Okay, so this was the code. So Dantlo, yeah, oh, not this. So Dantlo, if you see here, don't worry, we will also do one or two projects like this, end-to-end projects. Okay, so Dantlo we'll have the code in this way. Okay, it is opening, we'll show you, and this will be the deployment code. Okay, so backend lo run అనేది ఈ code. Okay, so and actual code అనేది ఇది మనం ట్రైన్ చేసిన notebook అనేది ఇది. Okay, so and ultimately see all this we are going to do. Okay, ఈ model initial గా ఈ data తీసుకొని దాంట్లో మనం encoding చేసి, okay, lot of things. Okay, whatever you studied till now is that's just I would say 20%. Okay, so actual machine learning start అయినప్పుడు the real applications లో you will have lots and lots of interesting things. Okay, see correlation check చేస్తాము, some visualizations చేస్తాము. Okay, and data and divide చేస్తాము, నీకు some graphs ఉంటాయి. Okay, after that finally we have tried with different models. Okay, so XGB regressor యూజ్ చేసాము, ఇక్కడ linear regression యూజ్ చేసాము, ఇక్కడ random forest regressor యూజ్ చేసాము. Okay, and decision tree regression యూజ్ చేసాము. Okay, and then finally we got some model. Okay, and if I just show you the model, let me run the model. Okay, so ఈ app అనేది finally, see, when I run this, it is telling me the app is actually running. Okay, over here, if I click on this, it will open the web app. Okay, so what is this web app? Web app అనేది user interface. Okay, మనం నేను ఏదైతే ట్రైన్ చేసామో, see for example మనకి ఇక్కడ యాక్చువల్ ఇన్పుట్ ఇచ్చినప్పుడు దిస్ ఈస్ ద ఇన్పుట్ గైస్. ఓకే, ఇన్పుట్లో ఏమేమి ఉన్నాయి? ప్రోడక్ట్ కేటగిరీ ఉంది, ప్రోడక్ట్ ఉంది, సేల్స్ ఉంది, క్వాంటిటీ, ఇవన్నీ ఉన్నాయి. ఫైన్. సో దీంట్లో మనకి అవుట్పుట్ అనేది ఏంటి? సేల్స్. ఓకే, దిస్ ఈస్ అవుట్పుట్. ఓకే, అపార్ట్ ఫ్రమ్ దిస్ ఆల్ దీస్ ఆర్ ఇన్పుట్స్. ఓకే, నా యూస్ కేస్ ఏంటంటే ఐ విల్ గివ్ ఆల్ దీస్ ఇన్పుట్స్, ద మోడల్ షుడ్ ప్రెడిక్ట్ మీ సేల్స్. ఓకే, ఆర్ యు గైస్ దేర్ విత్ మీ?
Yes, sir. Yes, sir.
చెప్పు కార్తిక్.
Once can you please stop recording?
Stop recording. Okay, I'll pause it. Just give me a second.
Yeah.
Recording. Okay, yeah, all these are open source e-commerce. Okay, general data, normal data, we have picked it up, and you can also find this e-commerce if you just type, right? So yeah, I will show you once we start learning, right? See, you can just cite ML e-commerce data set. You will have hundreds of, you see, Kaggle lo untadi, iMerit lo unta, data world, so many websites are available. Okay, so you will also find it so easy once we are done with the concepts, right? So you can take any website. For example, see, I'll go to there is some very UCI machine learning repository. Okay, once you open over here, you will have hundreds of websites. Okay, see, iris manam chusam kada. Okay, heart disease, some adult income, wine, breast cancer, diabetes. Okay, so many data sets, and you can also search for data sets. For example, insurance. Okay, I just want to search for insurance company. Okay, data set. Okay, see, this is some insurance company data set. Okay, so there you are using regression. Okay, and can you just tell me some other example? What was that? Okay, company sales. Okay, just if you want to sales. Okay, I'll just search for sales. Okay, sales సంబంధించిన data set ఉంటుంది. See, wholesale customers. This is a classification. You can also do clustering. Okay, this is clustering. This is clustering. This is regression. This is classification. Right? You can just download that data set. You can play with that. You can do classifications. You can do model predictions. It will be very easy. Okay, once we are done, that is how you will learn. Okay, all these are open source. You can just experiment, and that is how we will learn. Okay, so దీంట్లో our aim was to do that. Okay, so once we have done that, so we have built this. Okay, దీంట్లో see, when I am doing this, for example, I am giving some number, discount and some 5, okay, profit and some 40, shipping cost some 22. Okay, auto accessories అనేది electronics. Okay, for example, if you see over here, auto, see, product category low, we have so many, it is showing only auto accessories because I am printing only 5, but there are also other categories. Okay, product low, we are having car speakers, media, something. Okay, over here actually there are so many. Okay, let me take t-shirts. Okay, so when I say predict, it is giving me, okay, because I think my discount is more than my profit, that's why it is giving me negative. Okay, for example, if I give some quantity anedi, if I give 10, okay, discount anedi very less discount, okay, 0.2, okay. Obviously మన ఇన్కమ్ అనేది అవుట్పుట్ కన్నా తక్కువ ఉంటే ఇట్ విల్ బి మైనస్, రైట్? సేల్స్ అనేది, ప్రాఫిట్ అనేది ఐఎమ్ గెటింగ్ గుడ్ ప్రాఫిట్, ఓకే. కాస్ట్ కూడా ఐఎమ్ హ్యావింగ్ ఓన్లీ 5 రూపీస్ కాస్ట్, ఫర్ ఎగ్జాంపుల్, ఓకే. అండ్ హియర్ ఫ్యాషన్, okay, and here jeans, okay. So now see, my profit is 542. Agree? So this will be your end goal, guys. Okay, so whatever you have studied, right, after that you have started with Python, okay, you are going to stats. From there you will learn some tools, okay, 3 tools: NumPy, Pandas, Matplotlib. From there you will study some machine learning techniques. From there you will fall into the actual machine learning part, okay. After that you learn deployment also, how to deploy. Finally you can do what? You can just take any random data set, go here, download it, okay, and use lots of different techniques, and you can build your models, experiment with the different models, okay, and deploy them like this, okay, so that you can present to someone. You can just say, see, for a third person, okay, let's say you can just share it with your, even someone who don't know machine learning also, you can show this to your parents. You can say, I built this website, just enter as a third person, as a user, customer will not know any technical details, right? You can just present and just say enter some values, you will get the prediction, okay. So this is your end goal. So once you are good with the end to end, right, so obviously that's a good improvement, I would say, okay. So when you click this predict, what happens? So I will tell you in detail when we are learning, but just to show you from how linear algebra will be important, okay. So when you click that, everything is running from this app.py. Why? Because how we got that app? Because we ran this run app.py, okay. Ante ikkada app.py undi kada. So over there it will click. So over here, if you see, when you click the predict, okay, so over here, whatever the model we have trained, right, so that will be over here, a linear regression model we have trained. And see, when you click this predict on the website, so this will trigger this definition of predict, whatever you have, right? See, app.route predict. See this one. That means at the rate app means whenever someone is clicking predict, okay. So over there, it will come and trigger this function, okay. So over there, whatever the values you are putting over here, there will be in the form of input. It will take, see, float request.form quantity, discount, form, shipping cost, okay. Whatever you put over here, quantity, discount, profit, shipping cost, it will be considered from there. And product category, product, okay. So this we need to again map it, okay. This is what we have done. And finally, see, e-values తీసుకొని, see, I'll just give an overview. E-values తీసుకుంది కదా, e-values తీసుకొని, but how you are going to get the output? Who is responsible for giving the output, guys? Can you tell me who is responsible to generate the output? Just guess it. Who will give the output? From where the output will get generated? Okay, model. Fine, model will give the output, because whatever, that is the reason we have trained the model, right? So over here we have this model, okay. So from there you will say model.predict, okay. It will take all these inputs and it will pass them to the model.predict, okay. Model, we have predict button, it will predict. So once you predict these values, okay, so internally what will happen means, see, all these inputs are there, right? That will be one dictionary, sorry, one matrix, okay. In this model, okay, in this model, it is just a weights, okay. That will be one more dictionary, okay. That will be one more dictionary. So now multiplications will happen for the given input and for this weights. Whatever the output you have, the end output, that is the value, that is the sales, that is the prediction, okay. Ultimately that is a sales, okay. The value which you are seeing over here is coming from that. Getting? So that's how internally it happens. Are you getting this?
Yeah, Santosh.
Just at a high level, okay. At this moment you will not understand so much of it, but that's fine. At least a rough idea. Are you getting what's happening and anything? Okay, see, this is a model we have trained it. Okay, so this linear regression. So inside this is a linear regression model. Okay, this will be a collection of weights. Okay, that's it. I will show you sometime when I expand this and show you. Okay, fine. So that is just intuition of linear regression, I would say. Okay, so now let's start with some basic matrices. Okay, fine. So over here, fundamentally, we are going to use NumPy. Okay, so NumPy is one of the most important, I would say, library for data science specifically, and the abbreviation of this is numerical Python. Okay, NumPy means NUM stands for numerical, PY stands for Python. Okay, numerical Python. So where it is mostly used for so many numerical calculations, matrix calculations, array calculations, etc. Okay, and the way how you import NumPy is this way. Import NumPy as NP. Okay, so when you say NP, so from now onwards you should use NP. Agree? Fine. So initially, first of all, if you want to create a multi-dimensional array of all zeros, np.zeros. Okay. So now np is what, guys? Np is numpy. Okay. Inside that you will have hundreds of functions. Okay. So you will have hundreds of functions. Okay. So just to give you an idea. Okay. Just to give you an idea inside numpy. So I always suggest you to follow the official blog. Okay. Every numpy or every data science related library will have its official blog. Okay, for example, for numpy it is numpy.org. Okay, for pandas it will be pandas.pydata.org. Okay, and for scipy it will be scipy.org. Okay, and for sklearn it will be skykitlearn.org. Okay, these are the official blogs. Okay, this will be mostly updated, very much updated, and very much closer to the truth. Okay, so for example, if you see here in numpy, okay, so for example, if you have numpy once, okay, so once you click over here, see inside numpy how many functions you have. Numpy empty, identity, all these functions. Okay, but the trick here is we are not going to study all of this, and that is not the way. Okay, we are going to see the main things which are required for our machine learning purpose, and you should have the ability to understand those functions. And in future, whenever any other function is required, you can come back to this block and you can understand it by yourself. Okay, because if you just want to study all of this, that is absolutely useless, because you're not going to use all of this. Okay, you're going to use some of the main, for like example, ones, zeros. Okay, array. Okay, and see this as contiguous array. I have not seen anyone using. From buffer, no one using. From dp, like I don't know what is this. Okay, so all these are like the complete index. Fine, but the way to complete the course, I would say, which I followed, right? So study, it's called as reverse engineering, guys. Okay, so what is engineering? Engineering is like studying everything from the in a very detail. Okay, which will take you years together, because if you want to study only numpy will take at least 6 months to be perfect. But that's not the goal. Your aim is not to become a numpy expert. Agree? Your aim is to become a data science expert. Fine. So over there, that's the reason. That's where I also studied. NumPy, you grasp all the required basics. Pandas grasp all the required basics. ML, obviously, we are going to cover all the ML. Fine. Once you start building the models, obviously, you will find some requirement for some, let's say, some other pandas function. Let's say I'm going to cover 20 pandas function. That will be more than enough. But in case if you require one, you can quickly come back, because you already have some familiarity with the pandas. You can quickly come back to the official blog and as per your requirement, find any function, and you will not have any difficulty to understand or implement this function, because you already have the basics. It will be some little change in that whatever you already learned. Okay, that is the way the plan should be. Okay, so even the I would say in the stats also, if you want to study the whole stats, it will be more than 6 months, and that it will not be that helpful. I'm telling you honestly, because studying 6 months completely stats will first of all, it will bore you, and second thing is it will not that much helpful to achieve your goal in the data science course specifically, because our goal is to have the overview of every concept and try to be a job ready person for the data science interviews, right? That is a goal, at least for this course. Okay, But having said that, we are going to cover what all that is required for you, okay, which is expected for you from you. Fine. So, and I also suggest anyone, not only you, outside the course also, I suggest anyone to do the reverse engineering. What is reverse engineering? Study what basics of everything, what all that is required, and start building the models. Okay. Once you start building the models, obviously you will find you want, if you find somewhere that you are lacking something, just come back and study those, and again go to the end goal. And again, you will find some more function, you will come back, study those, and go back. That's called reverse engineering. So which is more practically oriented. Instead of taking 1 year, see, instead of taking 6 months NumPy, 3 months pandas, or 5 months Python, 6 months statistics, over here only you will lose more than, if you say 2 years, guys. Fine. And studying everything without any practical application will obviously boring, at least for me. Okay. That's why have the basics, start building something. Okay. Then wherever required, go back and build. Okay. Then, okay, initially your NumPy will be this, stats will be this, pandas will be this, okay, this, and you will go and start using the ML. Okay. Over there, while doing EDA or feature engineering or encoding, obviously you'll require a lot of other functions. Okay. Then you'll come back and increase your NumPy a bit more. Keep on adding that. Okay. Pandas, learn 1 or 2 functions. Okay. Or Python, try to optimize your code or learn some techniques. Okay. That's where you will have 360 degrees improvement instead of only, okay, one particular category improvement. Okay. Are you guys there with me?
Yes, sir.
Fine. So now let's start with NumPy zeros. Okay. So what is NumPy zeros? When you create NumPy.zeros 344, so you are creating a multi-dimensional array, which are all zeros. That means 344, 3-dimensional array. So outside you will have 3 set of zeros, and inside each set you will have a 4x4 matrix. Okay. 4 rows, 4 columns. Okay. Like that you will have 1, 2, 3. Clear?
Yeah, Santosh.
Okay. So now if I change over here 2x4, so you will have 3 set of zeros. Okay, but inside that you will have 2x4. That means 2 rows, 4 columns. Okay, simple. All this will be simple functions itself. Okay, don't worry. And same thing for ones. Instead of np.zeros, you have np.ones. Same thing, 2, 3, 4. Okay, so you will have 2 sets of ones, but inside each set 3 rows and 4 columns. 1, 2, 3, 1, 2, 3, 4. Okay, fine. And now coming to vectors. Okay, so let's say you have 2 types of 2 vectors or matrices. Okay, x and y. Simple, x plus y will give you the sum of these numbers, and np dot add. Okay, yeah, that's a difference. See here, what is the x, guys? What is the data type of x?
List.
Oh,
List.
sorry. List. Yeah,
Right?
sorry.
Fine. So when you do, yeah, a equal to 1, 2, 3, right? B equal to 4, 5, 6. The fundamental, this actually I will show you with proof in NumPy class, but just because we came across this, I'll show you. See, when you do a plus b, you will not get addition of this. It will just add both of this. Okay, it will make into one single list. Fine, 1, 2, 3, 4, 5. It will just concatenate both and give you one single list. Okay, but this is not our requirement, right? Mostly when we say a plus b, we want the elements to get added, right? We want to do mathematical addition, not simple concatenation. Okay, so that's why if you see x xy, print type of x will be this one, it's just a concatenation. But when you say np.add, okay, when you use np.add, it gets added. So you will have 4 plus 2 6, 5 plus 9 4, and 6 plus 6 12. Okay, 6 9 12. That's how you will get added. Okay, and after that you have something called as np.cross products. Fine, np.cross product. Okay, cross product of these. Okay, so now coming to matrix multiplications, right? So matrix multiplication, there are like 3 types, I think. Matrix, we all studied matrix in our school days, right? So one will be the scalar matrix. Okay, scalar products. That means what, given a matrix, if you multiply with some value k, it will be multiplied to each and every element. Okay, and next it will be dot product, you might have seen, and also cross products. Okay, there's some cross product. Fine. So this is a cross product. And what is a cross product? I'll just give you a quick overview. For example, if you see you have a equal to 1, 2, 3, b equal to 1, minus 2, 1, minus 1, 2. The cross product will be, see, these 2 values, okay, into these 2 values. Okay, initially these 2 into these 2 minus, okay, minus these 2 into these 2. Okay, see, first of all these 2, Next, once that is done, you will have this first row and third row into these two. Okay, this minus j into. Okay, and next, finally, you have first and second row. This into
Yes.
this. Okay, so we'll see with an example. In that case,
Try to eliminate first row, first column. In first case, no, sir.
yes, I'm showing. So you are having 2, 4, 6. Okay, then you have 4, 5, 6. Okay, so first is
24 minus 30. Sorry, 24, 6, 5, 6.
24 minus 30. Okay, okay, minus. Okay, initially these two. Okay, after that these two. Okay, that means 6 to the 12 minus 24. Okay, after that plus these two.
20 minus 60.
10 plus,
Plus
sorry,
or
minus.
minus, yeah.
10 minus
16.
Okay, so it will be plus minus plus. You observe? Plus
Yes.
minus plus. Okay, so over here, so obviously it will be 24 minus 30. What was it? Minus 6.
Minus 6.
Okay, and this is minus 12, minus into minus plus, plus 12,
And minus 6.
and this is minus 6. Okay, so minus 6, 12, minus 6. You got here minus 6, 12, minus 6. Okay, so that is a cross product. Okay, so whenever you want to do cross product, simply np dot, you don't need to do all this. Okay, whatever I'm showing practically, right? You don't need to do all this, just to have functions, but I'm just explaining you manual. Okay, so np dot cross will give you x and y, it will give you the clear cross product. Clear? Any doubts?
Yes.
Cross product? Okay, fine. So next we are going to go for the few vector concepts. Okay, next we have seen something scalar multiplication is. That means given a matrix, it is a scalar. Okay, when you multiply with scalar, it will just multiply with every element. 4 to the 8, 2 into 0, 0, 2 minus 18. Okay, simple scalar multiplication. Okay, initializing matrices. Yeah, so over here if you see scalar product is n into something will be n into each and every element, it will multiply with n. Okay, and matrix addition will be what? Element to element. Okay, a plus g, b plus h, c plus I, d plus j, matrix addition. Okay, element to element wise. Okay, after that you have matrix multiplication. Okay, this is not the vector cross product, guys. It is a matrix multiplication. Okay, so you remember, so what is the size of this size of matrix? 2 rows,
2 by 3.
2 by 3. Okay, and this one 3 by 2.
3 by 2.
Okay, so if you remember, we can do matrix multiplication only when the columns of first matrix is equal to the rows of second matrix. We used to do like 3 3 cancel, then you will get a 2 by 2 matrix. Okay, the output will be 2 rows 2 columns, 2 by 2. Okay, you can do matrix multiplication only when the column, the second element columns of first matrix is equal to the rows of the second matrix. Okay, then the output will be 2 into 2. Okay, so and the way how you can multiply is this: a with first element, sorry, first row into first column, and again first row into second column, second row into first column, second row into second column. Okay, see, first row into first column, that means what? A into g, b into I, c into k. Clear? Again first row into second column, a into h, b into j, c into l. Okay, now second row into first column, d into g, e into I, f into k, and again second row into second column, dh, ej, fl. Is this clear?
Yes, Santosh.
Okay, fine. So now if you do MP dot addition, so what are our matrices? Okay, these are our matrices. Okay, so let me just check. So this is our X and this is our Y. Okay, so when you do element wise addition, okay, you will have 7 plus 1, 8, 8 to the 10, 13 and 15. Okay, that is NP dot add. Okay, subtract will be element wise subtraction, simple. Division will be element wise division, simple. Each element wise element wise, and multiplication will be the matrix multiplication. Okay, just know what we have done. That is what they will do. Okay, so see, I will just show you one element. It will be similar for the same other. Okay, you have 1, 2, 4, 5, and it will be 7, 8, 9, 10. Okay, so what is the size of this? 2 into 2, and what is the size of this? 2 into 2. Okay, so 2 will be cancelled. Output will be 2 into 2. And what is the output in the this first element? Okay, the first element you will get from first row into first column. That means what? 1 into 7 plus 2 into 9, 18. Okay, and this one you will get it as first row into first column, 8 into 1 plus 10 into 2, 20. Okay, fine, I'll do for everything. 4 into 7, 28 plus 9 5 is 35. Okay, and oh, 9 5 is 45. Sorry guys, I'm forgetting tables. Okay, 8 4 is 32 plus 10 5 is 50. What is this guys quickly? Same thing. Oh, did we get different? Okay, input dot multiply will give us element wise multiplication. Okay, I did different thing. Okay, this is matrix multiplication. Okay, sorry, this is whatever I have done is it's a matrix multiplication. Okay, element wise multiplication, np dot multiply will simply give you what? Will simply give you element wise multiplication. That means what? Element into element. 1 into 7, 7, 8 into 2, 16. Okay, 1, 16, 36, and 50. Clear? Guys, getting or not?
Yeah, getting Santosh.
Okay, so what I have just shown you, that is a dot product, guys. Okay, what this multiplication, what I have done, that is a dot product. Okay, see, when you do np dot, you will get this 18 plus 7, you will have 25. Okay, 25, and 10 plus 20, 8, 28, and this will be 73, and that will be 82. Okay, so whatever I've just done is that is a dot product. Okay, a normal element wise multiplication will be multiply. Okay, see, just to summarize, there are 3 types of multiplications. Guys, multiplications are 3 types. One is simple scalar. What is scalar? N into some matrix will give you each and every element, it will multiply with that element. Okay, second thing is cross products. Cross products. In cross product, what we have done? Okay, if it is like 1 2 3 and it is some 4 5 6, in cross product, what we have done, it will be this element minus this plus this. That is cross product. Getting? Next is dot product. In dot product, what is happening? Okay, in dot product, the matrices are with the formula: first row into first column, first row into second column, second row into first column, second row into second column. Okay, that is dot product. After that, we have the actual matrix, simple matrix multiplication. What is this? Element wise. Element wise. Okay, that means what? You have matrix, first element into second element, first into first, second into second, third into third, fourth into fourth. Okay, total 4 multiplications we have. Scalar, simple cross product, this formula, dot, the actual row wise, element wise, matrix, element wise. Any doubts, guys? Are you following?
Following Santosh.
Others?
Yes, sir. Following.
Great. Okay. So now np dot multiply is simple, and how to do it? How to do it practically? I mean, in the using the code. Okay. In scalar is directly k into that matrix, nothing more. Okay. Cross product is you will use np dot cross. Agree? We have used, right? np dot cross gives you that np dot cross. Fine. And dot product. Now coming to dot. Sorry. np dot will give you dot product. You have seen that np dot. And normal element wise will be np dot multiply. Sorry. This is np dot multiply. Okay. Practically you can do it simply. Cross dot scalar is simple as there is nothing much to remember. But cross is cross, np dot is dot, simple, and multiply is element wise multiplication. I hope that's clear. Okay, fine. So after that, we are going to see the same things. Okay, x equal to 1, 2, 3, 4, 5, 6, np dot cross product. Okay, so same multiplication cross product, you can apply that formula, you will get this. Clear? And after that, yeah, cross product, you can also apply it for different sizes of the matrices. Okay, and np dot array, there are two arrays, dot product. Fine. So for the dot product, okay, what is dot product? So these values. Okay, so if you have 2, 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6, 7, 8. So in this case, what you are going to do? Fine. So you are going to multiply row wise. Okay. So 1 into 5 plus 6 is 12, 21, 32. So when you add that, you are going to get what? Dot product. Okay. So for example, if you see 1 into 5 plus 12 plus 7 to the 21 plus 8 for the 32. You got 70. Okay. Your dot will give you 70. Okay. And coming to next, you have something called as transpose, guys. Okay. Transpose means what? Rows will be converted into columns. Columns will be converted into rows. It's called transpose. Okay. So even in Excel also you have. Okay. Even in if I just show you some Excel also. Let me see. We have an Excel. Some Excel file. Simple Excel transpose. See, for example, I'm copying this. Okay, if I just simply copy, I will have this. But if I copy and when I do this symbol, paste special, no. This. Well, it will be, it should directly show actually. Paste special, where is a transpose? You should get it over here only. Copy is copy, but normally it will be formula transpose. Over here, transpose, you see. Okay, so rows will be converted to, sorry, column converted to rows. Okay, that's how you can do. But over here, you can just say X transpose. Okay, so the way how you can do over here is you can directly say X dot T. X dot T, capital T will give you transpose. Getting? So when I do X equal to this, okay, yeah. Okay. Okay. Yeah, there's an interesting point here, guys. See, so actually, if you see here, I am having x equal to np dot array 1, 2, 3, 4. Now, if I print x, what is this? This one, okay. And when I say x dot to get the matrix size, I think size 4. Okay. But when I do x dot transpose, okay, when I do x dot transpose, it is I'm actually again getting 1, 2, 3, 4. Fine. It still I'm getting in the rows only. It's not getting converted into the columns. The reason here is, the problem here is, it only works if we declare the variables not to be arrays but in a fact of a matrix. Okay, we need to declare that in the shape of matrix. How you will do? You need to give 2 braces, guys. Okay, so when you put it in 2 braces, okay, now it get converted into 1, 2, 3, 4. Agree? 1 brace will be arrays, two braces will be matrix. Okay, so transpose will work only for matrix. The way you can do it, simply put it in two braces. X dot transpose will give you this. Okay, getting?
Yes.
Okay, so same thing, y transpose, x transpose, simple. Okay, and what do we have? Okay. Yeah, so you can combine what all we have studied. X is this. Now you can do np dot, okay, and y transpose. Why, guys? Because see, as I said, x equal to, if you want to do dot product of two things, the rows of here you will have rows, columns, and here you will have rows and columns. Okay, the column of first matrix should be equal to the row of the second matrix. Okay, so over here, but when you consider only normal matrices, here it will be, if you have three values, 1, 2, 3, this, what is the size of this number of rows into columns? How many rows? One column into three. So one row into three columns. Okay, and what will be the size of this? If you have some 4, 5, 6, this also 1 by 3, right? So, but you cannot do, because 3 and 1 are not matching. So that's why if you transpose this, that means if you transpose this into a, it is actually row matrix. If you have only one row, it's called row matrix. If you transpose this to a column matrix, that means if you make it into 7, 5, 6. Okay, now what will be the size of this? Size of this will be
3 by 1.
right. It will be 3 by 1. Now this 3 gets cancelled and the output will be 1 by 1. Means only one element you will have. Okay, so that's why what we have done, x and y dot t, y transpose. Now you're using np dot x and y dot t, not y. So this is x, this is y transpose, and the output is only one element you will get, y. So 3 cancel, only 1 by 1. Means this is only one element. That's a matrix. Okay, that's why you got 17. Or reverse also you can do. Y, instead of x and y dot t, you can do y comma x dot t. That is also you get the same value, because the order is not important. Okay, is it clear?
Yes, Santosh.
Okay, so now next we have something called as compute the outer products. Same thing, you can also reshape. Okay, so transpose is one way, and second thing is reshaping. Okay, so reshaping of the array is, see, you have x dot shape. X dot shape is 1, 4. Okay, so all this we will see in numpy, but see, x dot shape is how many rows into how many columns? 1 row, 4 columns. It is saying. Okay, now when I do x transpose, okay, x dot transpose, I got what? This. Okay, and now when I do shape, it is 4 by 1. Okay, rows will become columns, columns will become rows. Okay, but instead of doing that, you can also do reshape. Okay, np dot reshape this way. You can also convert it into np dot reshape x comma 4 comma 1. That means you want this to be converted into 4 comma 1, because earlier this is 1 comma 4. Now if you want to convert it into 4 comma 1, just say np dot reshape 4 comma 1. Okay, now it will be converted in, this is converted into this. Getting?
Yes.
You can also do different shapes also. Say I want to convert it into 2 by 2. Okay, transpose is what? Just rows will become columns. 1 by 4 will become 4 by 1. 2 by 3 will become 3 by 2. Just opposite, transpose. Okay, but if you want to do some other shapes, for example, 1 by 4, I don't want it as 4 by 1. I want it as 2 by 2. Okay, so you can do it as 2 by 2. So the 1 by 4 will be converted into 2 by 2. Okay, fine. So after that, same thing. So when you have x is this one, and x transpose, see, x is this one, I am multiplying x transpose with y. Okay, so x transpose with y is giving you this value. Okay, and numpy dot outer, okay, we can compute the outer product by multiplying the column x vector with the row vector x. Okay, we'll see how it's working. So first of all, we'll try to understand what is x. Okay, x, this is x. Okay, and what you are multiplying? You are multiplying x transpose. Fine. So now what is x transpose? X transpose is this. Okay. And now what is Y? I'm multiplying with Y. Okay. But what is Y? Y is array of this. Okay. 7, 8, 9, 10. So when you multiply this with this, you are going to get, oh, first of all, I need to run this, right? Let me run this. Okay. So X transpose is this, Y is this. So how you are going to get, so 1 into 5, 5. X transpose this, and you are going to put Y over here. Okay. 5, 6, 7, 8. Okay. So each element into another element. Okay. 1 into 5, 5, 1 into 6, 6, 1 into 7. See, into means normal element wise. Okay. And next, 1 with all rows, guys. 2 with all rows, 3 with all rows. Okay. 2 into 5, 10, 12, 13, 3 into 15, 18, 4 into 20, 24, like that. Okay. Simple matrix multiplication. This multiplication. This multiplication, not cross, not dot, simple multiplication. Okay. If it is cross or dot, you need to specify, or else it is simple, this multiplication. Okay. Fine. So after that, np dot outer product is also the same thing. Okay. After that, what you have dot product. Okay. I just told you what is dot product also. So the way how you can do row column, that is that product. Okay. After that, what? Matrix multiplication. Okay. Matrix matmul. Oh, what is this matmul? I also forgot. So see, as I said, I also not remember all the things, right? So it's simple because I already studied this. Okay. So it will be easy for me to just recollect. Okay. For example, what is this np dot matmul? So whenever you also don't know. So just go here, numpy matmul. Okay. So go to some, yeah, official blog, matmul. What it is saying, matrix product of 2 arrays. Okay, so np dot 1, np dot 1. So 1 into 4, 4, 0 into 1, 1, 2, 2. Okay, normal multiplication. Okay, fine. So here also what we got. So for this, we need to first of all see what if you print only, you will get the size idea, guys, because it is looking like this, right? But when you print it, it is actually yeah. So for example, if I print B, and if I see the size of B, B dot shape, oh sorry, okay, you will know. Oh, what is this list? Oh, okay, acha, okay, this is normal list, right? See, but because we did not mention it as np dot array or anything, so but if you say np dot array, if you mention np dot array, then that will be array. Okay, so in this case, what happened, guys? 1 into 4, 4, 0 into 1, 1, 0 into 2 into 2, 2 into 0, 0, 2 into 2, 2. Okay. Can someone help me to understand this? Any guesses? 1, 0, 0, 1, 4, 1, 2, 2. Okay. From this, we got this result, 4, 1, 2, 2. What happened? This into this. Okay. 4 into 1, 4 plus 0, 4. Again, this into this. 2 into 2, 2, 0. I will get 0. Okay. 4, 0 into 4. No, it's not getting. Fine, guys. I need to check this. Okay. See, I don't use this for a long time, but it should be very simple. You can just go in np.matmul. From here, you can understand this. If you're not getting, I will spend some time and I'll let you know. Okay. Or else, what's happening here? 1 into 1, 1. 1 into 0, 1 into 0. Fine, I'll tell you later. Okay, fine. But matrix additions will be simple. Okay, 4 into 1, 1 plus 0, 2 plus 0, 2, 2 plus 1, 3. Okay, so it will be 5, 0 plus 1, 1, 1 plus 2 plus 0, 0, and this is this. Okay, and 4, 0, 0, 2. But if it is, no, my doubt was actually, see, if you do element wise, 4 into 1, 4 plus 1, 5. Okay, so it will be 5, 0 plus 0 plus 1, 1, 2 plus 0, 2, and 2 plus 1, 3. Right? 5, 1, 2, 3. Where I got 5, 1, 2, 3. Okay, but if you do the multiplication, 4, 1 is 4, 1, 0 is 0, right? I should get 4, 0, and 2 0 0 2 on the 2 4 0 0 2 you should get, but I'm getting 4 1 2 2. Okay, that I will check. No problem. Fine. After the dot product we have seen already. Agree? And normal multiplication. Identity. Okay, identity is that matrix where you have the diagonal matrix will be all ones and remaining all will be 0. You remember? Only in the diagonal you will have all ones and remaining everything will be 0. That is called identity matrix. Okay, that could be of any size. When you say input identity 5, you will have 5 by 5. Okay, identity will be square matrix. Square means what? Number of rows will be equal to columns. Okay, 2 into 2, 3 into 3, like that. Okay, over here it is 5. That's why you not mention rows and columns, because when you say 5, it is obviously 5 into 5. Okay, 5 rows, 5 columns. Agree? But all the diagonal will be 1 and remaining everything will be 0. Is it clear?
Yes, Santosh. So by default, it will take float, right?
By default, it will take float, yes. Yeah. You're saying something, Meghna?
Nothing.
Okay. So, yeah, you can create matrix like this shape. Yeah, the way how you can create identity is, yeah, see what they're doing over here. If you observe, they're creating a variable called as identity. This is not identity matrix. Okay, with a name identity, they're creating a array. This array, and what is the shape of this array? 2 by 3. Why 2 rows, 3 columns? Agree? This is the shape of a identity matrix. With this shape, they are creating a identity, actual identity matrix. Okay, so see, from this shape, what we are taking? They're taking. See guys, this is a matrix. They have created this identity matrix. Identity shape is this 2, 3. Now shape is 2, 3. Shape of 0 will be what? And shape of 1 will be what? Shape is 2, 3. Shape of 0 is 2. Shape of 1 is 3. Okay?
I didn't get you.
See guys. This is some identity, some matrix they are creating, guys. Okay, if you're getting confused, this is sample. I will call it a sample. Okay. Now this is sample. Okay. Some sample matrix I have created. Now what is my sample matrix shape? 2, 3. Okay. Now the shape is what? What is the data type of the shape? Data type is data type of shape.
Matrix.
No, data type. The Python data type.
Set.
Tuple.
Sorry. Tuple.
Tuple. Okay. So this is tuple. So if you see, it's a tuple. Okay. Now what is tuple? This tuple of 0 is what?
2.
Exactly. Okay. And tuple of 1 is what? 3. Fine. So now with this, they are trying to see, now identity becomes sample, right? So now I'm creating identity matrix. Okay, np dot identity with what shape? With sample dot shape of 1. That means the sample dot shape of 1 is what? 3. So indirectly they're saying here how they have created like simply np dot identity 5. Okay, instead of this 5, they are picking it from some other matrix shape. Okay, so this sample dot shape of 1 will be 3. Okay, so instead of 5, now it will be 3. So you will have a 3 by 3 identity matrix. That means you will have a 3 rows, 3 columns, all the diagonals will be 1. Clear?
Yeah,
No.
clear.
Yes, sir. Understood.
Okay. And just to tell you, Karthik, by default, it will be float. Okay. But if you want to change, see, this is how they're doing. Data type. D type is data type. If you want int, it will give it as int. By default, it will be float. Okay.
Okay.
And you can also do shape of 0 also. Shape of 0 is what? 2 by 2. What is shape of 0? 2. That means identity will be 2 by 2. When you give sample, it will be 2 by 2. And what to say, the diagonal will be 1. Okay, fine. So after that you have inverse matrix. Inverse means it will do the what you will have. Inverse means the rows will become columns, columns will become rows. But what is the difference between that and the transpose?
Transpose.
Yeah, matrix inverse. Okay. So, oh, okay. Inverse of matrix is this. You will have formula, right? So 1 by A into adjacent of A.
So,
You remember? We used to do this matrices. See, I'll just give an idea. See, the inverse of matrix is found by the below formula. So you need to do this. You need to do 1 by, if the matrix is A, B, C, D, 1 by AD minus BC into D into minus B minus C. Okay. When you do this formula, right, you will get this. You will get this. Okay. So, for example, if I take this, look at simple 1, 2, 3, 4. Okay. So what is the inverse formula, guys? 1, 2, 3, 4 inverse formula. I will do here only. Can you tell me? 1, 2, 3, 4. Okay, it will be 1 by what is AD minus BC? 4 minus 6 minus 2. Okay. And what is D? D will be 4 and minus 2 minus 3 and 1. Agree? And now
Yes.
what is this? What is this, guys? How much this will be? You need
Minus
to
2.
multiply this with
Minus 2.
everyone.
Minus 2.
Minus 2, 1,
1.
3 by 2.
Minus 1 by 2.
Minus 1 by 2. Okay. Inverse, simple. So I'll go over here. Inverse. Okay. So sample, put the sample over here. Let's see if I get the same thing. Okay. Minus 2, 1, 3 by 2 is 1.5 and minus 1 by 2 is minus 0.5. Matching?
yes, sir.
Okay, perfect. So we understood inverse also. Okay. So what all we have seen, guys? We have seen different types of multiplications. We have seen what NP dot ones we have seen. Okay, just to recap. Okay, we have seen NP dot zeros we have seen. Okay, and we have seen what transpose we have seen. Okay, we have seen inverse. Okay, and okay, fine. This should be actually more than enough, but fine. Then we have seen, yeah, we have seen identity. Okay. Fine. And what we have, diagonal matrix. Diagonal matrix is what? Diagonal, this we will see. See, diag of A. This is interesting. See here, np dot numpy dot ap, right? Np dot, this is array. When you say, when we in numpy, we can create a diagonal matrix from a given matrix. Okay. So over here, you are having np dot array. When you say diag of A, you are getting 0, 5, 10, 15, right? K equal to 2. Okay. So this is a bit interesting. See, diagonal matrix. Okay, so over here, you will say with the help of K. I'll show you it. Actually, I had this in my images, but my system got corrupted, guys. So that's why I lost those images. Otherwise, I would have shown you immediately. But however, I will show you. Okay, with the K. What was that? It's called np dot diag. Yeah, we can directly go to np dot diag. Okay, np dot diag. The K value. Yeah, K is an optional. Okay, when you do K, right, you will get some interesting values. You go to images, you will have the K. Where is K? Let me find the K. Where are you, man? Oh, it's called trace, actually. I think it's called, is it trace? No, it's not trace. K equal to 3. Input dot K equal to 1. Okay, that when you give K, right, it will pick it, it will consider it as minus 1, minus, yeah, let me see over here. K equal to 1. K equal to 1. Okay, 0, 1, 2. Okay, I think it is 0, 1, 2. If I remember it correctly, I'll show you. See, you are our aim is to create a diagonal matrix, right? So over here, this will be 0, guys, k equal to 0, okay? And above it will be 1, 2, 3, -1, -2, -3, okay? See, I will show you, will understand. So when I say simply k equal to 2, yeah, 0, 1, 2, k equal to 2 means 2, 7, right? Yeah, so observe, guys, over here I'll let me take a picture, you will understand clearly, okay? So yeah, so see, guys, over here it's simple, nothing fancy over here. When I say this value is there, right? That means this is k equal to 0, okay? Next one, this is k equal to 1, okay? This is k equal to 2. If you want to just strip the matrix and take only this is k equal to 3, okay? Above it will be 1 and this will be what?
-1.
Yes. Okay, that's it. Fine. So if I just go here, yeah. So if without saying anything, by default it will be 0. So which one I will get, guys? Which one I will get? It will be k equal to 0 will be k equal to 0 will be what? 0, this value 0, 5, 10, 15.
10, 15.
Okay. The same thing you are going to get over here 0, 5, 10, 15. Fine. But if I say k equal to 2, okay, input dot diagonal matrix. But if I want to, that means which diagonal you want to take? All these are diagonals, right? The inner meaning is take the diagonal. The actual diagonal is this. When you say from this corner to this corner, but you can this is also diagonal. This is also diagonal. Everything is a diagonal. Which diagonal you want to take, that you can give what is controlled by the k parameter. Okay. So now when I say k equal to 2, what happens, guys? So when I say k equal to 2, what I should get? 2, 7. Agree? So that's why when I run k equal to 2, you get 2, 7. Fine. So as I said, now below this will be -1. So when you say k equal to -1, what you get? 4, this one, 9, 14. Fine. So when I say k equal to -1, you get 4 minus 14. Okay. So when I say k equal to -3, what I will get, guys?
Only 12.
12. Okay. So when I say k equal to -3, I get 12. And similarly, when I say k equal to 3, I get 3. Clear?
Yes, sir.
Simple. Okay. So this is regarding the diagonal. So we have also seen something called as diagonal matrix. Okay. And after that, what do we have is transpose. We have clearly seen the transpose, A dot transpose, rows, columns, rows. Okay. And what is a symmetric? If a matrix is equal to its transpose, it's called symmetric. It's simple. If matrix is equal to its transpose. Okay. For example, which matrix will be equal to its transpose? All identity matrix will be equal to transpose. Okay. 1, 1, 1, 1. If you do transpose, you'll get the same thing. But if you have 1, 2, 3, 4, this is not a transpose, because when you do transpose, it will become 1, 2, 3, 4. These are not equal. Okay. But if we have 1, 0, 0, 1, 1, 0, 0, 1, this is also a transpose. If you do rows, column transpose, you'll get 1, 0, 0, 1. Okay. If a matrix is equal to its transpose, it's called symmetric. Simple. Okay. Then after that, the final thing which we have is called the trace, guys. And what is trace? Trace is written the sum of diagonals of the array. Okay. So what is this? When you have np dot I, what is I, guys? Identity. Okay. np dot I, this is I, and trace is nothing but the sum of the diagonal elements. That's it. Simple. What is diagonal? This is a diagonal. What is the sum? 3. That's called trace. Okay. And if you want to create some more matrix, okay, for example, which matrix shall I take? Okay, this matrix I'll take. Okay. So this I just ran, right? A equal to 1, 2, 3, 4. Now when I say np dot trace of A, Okay, np dot trace of A, I get 5 because diagonal is 1 plus 4 plus 5. Okay, so you can increase the values also 1, 3, 4, 4, 5, some 10. Okay, and if I do trace, it's you're also getting 5. Okay, it's considering this trace. Okay, but if I create it as a what the 4 by 4 square matrix. Okay, so I will have
Shape.
so I need to increase number of values, right? So if I increase, I want to reshape this as a, for example, I have this and I will try to reshape it as a np dot reshape A into 2 by 2. What it is not matching. 8 we cannot convert it into 2 by 2. Let me see this particular array. Okay, this array if I consider and check it as A. Okay, this is the matrix. This is having 8, and can I replace this as A? A is also 16 into 2 by 2. It's also not possible. Fine. So okay, this trace, if I just do trace of this, how much will get? 10, 20, 30. Okay, 30. Fine. Why it is not working? Don't worry. I will tell you in the NumPy when you're doing reshape. Okay, there are some rules. Okay, so because the shape of this is 4 by 4, right? 4 by 4 is 16. Agree? What is the shape of this? 4 by 4. How much that is? 16. That means what does this mean? 16 means what? Total 16 elements are there. Agree?
Yes.
But when I'm trying to reshape it into 2 by 2, how many elements are there? 4 elements. So I'm asking it to convert 16 elements into 4 elements. What will happen to remaining 2 elements? That will not work, right? So that's why it is saying it's not possible. Okay. So, but 16, from how, in another way, how can you get 16? 8 to the 16, right? I can do it into 6, 8, 8, 8, 2. Getting? Because the multiplication value should be same. The number of, we cannot like delete any elements, right? So this is a 4 by 4. So 16. So whatever you do, you should get 16. 8 by 2 is 16. It will work. 2 by 8 is also 16. It will work. Okay. So and 16, 1 will also work. Okay. But 18, 1 will not work. It will say there are 16 only. How can I convert it into 18? It will scold us. Okay. So 16 will also work. Clear, guys? Is this clear?
Yes, sir.
Yes.
Okay. So and trace is also this one. So when you do trace, it will just the simply whatever you have. And one more thing is we have also seen that trace. Fine. So yeah, guys. So that, and after that, what do we have? Matrices, trace. Yeah, that's all. So I would say this is the basics matrices you should know. That should be more than enough actually. Agree. So I just want to cover this and mostly multiplications and these basics. If you know, that's fine. You can go to the class again. Fine. So with this, we are done with the basics linear algebra that is required. And the next concept we are going to start here is, let me just create new section. It will be NumPy. Okay. So we are going to start NumPy from Monday. What you are going to get it on? I can start it tomorrow, but again there will be a break. Okay, so let me start it on 11th. Okay, on 11th December we'll start NumPy. Fine. So that is a plan, and I will try to. It might take some 3 to 4, mostly 3. I will see over the weekend. I will see how many classes it will take. Okay, but as I said, NumPy, next pandas. First goal. Next step would be on from stats, right? First step was on Python. Okay, next step is on stats, and third step will be a combination of NumPy, pandas, and matplotlib. Okay, that will be your next step. Okay, and our fourth step is going to be feature engineering and the EDA. Slowly we will enter into the core ML. Okay, and after that you are going to enter the actual ML. Okay, over here we are going to see mainly regression, classification, and clustering. What all it is actually present in the data science course will be anywhere you will have this regression, classification, clustering. Apart from this, we are going to see tons of general topics. Okay, general topics you'll have like encodings you have. Okay, and you have like train test plate, you have optimization, hyperparameters, so many wherein like wherever it is required, right? So we are going to touch those concepts. Okay, and after that you also have different concepts as per the course, but next step is this, and actually now this is done, and this will be on Monday. Okay, cool. That's all I have for today, guys. Yeah, are we good?
Yes, sir.
So send
Fine.
stat
So,
notes to me.
yeah, sorry.
Stat notes.
Stat notes, yes. ఈ నోట్బుక్ నేను షేర్ చేస్తాను యాక్చువల్గా. ఓకే, సో ఐ షేర్ ద నోట్స్. ఈ కంప్లీట్ నోట్బుక్స్ ఉన్నాయి, ఇది షేర్ చేస్తాను. అండ్ ఆల్సో ఐ షేర్ ద 3 things I'll share. Okay, one is the notes. One is the one notebook. Second thing is the code, and also third thing is the Word document. Okay, 3 things I'll share. Mostly I'll say it by today or by tomorrow, definitely I will share. If I don't share it by tomorrow, guys, just ping me in the group once. I'll share 100%. Okay, so over the weekend, just wherever stats notes or prepare just go side bitman, that's the only advice. That should be good. Okay, come with fresh mind on Monday.
We have to thorough with the stats class.
For NumPy, no, not required. It is different. Okay, but for by the time we reach ML, pandas also, yeah, with pandas. Okay, in pandas you will use stats. NumPy not that much, but in the pandas when you start learning, you have describe function, you will use box plot. Okay, pandas is the actual thing which will be very useful. Okay, ఎందుకంటే మనం each data ni మీకు actual practical నేను చెప్పే బదులు practical ఇక్కడ చూస్తే, for example, if you see here what we have done in this whole project, first starting from the first line itself, it is pandas. PD is pandas. Okay, where it is pandas.pd, pandas as pd, numpy is np. Read చేయడం కూడా pandas pd.read. Okay, దాని తర్వాత whatever you are going to do, so this is also in pandas. Okay, this is also in pandas. Okay, head is also in pandas, and unique is also in pandas, encoding is also in pandas. Everything, see a data, some null values unnaya, drop చేయడం pandas, everything describe. See in this, I just said describe ఉంటుంది pandas. దీంట్లో ఏముంది, you have count, mean, standard deviation, minimum 25 quantile, 50% quantile, 75 maximum. So all this is in pandas. Okay, pandas లో సగం stats ఏ ఉంటుంది, information is in pandas. So ultimately 90% of the time మీరు pandas లోనే స్పెండ్ చేస్తారు. ఓకే, దాంట్లో మీకు చాలా దగ్గర స్టాట్స్ అనేది టచ్ అవుతూ ఉంటుంది. Okay, correlation you should have, which we studied in pandas. So if you are a little back in the stats class, okay, utilize this weekend. Okay, utilize this weekend. Okay, I'll share the notes. Okay, and try to at least main concepts ఏదైతే కవర్ చేసామో. Okay, so try to initial classes, univariate, bivariate, mainly quantiles and percentile, guys. This should be thorough. Okay, quantiles, percentile, and mainly normal distribution. Okay, central limit theorem. Okay, hypothesis testing, again we will see wherever it is required, but at least stats flow coverage in 70 to 80%, and if you are able to remember and grasp the things, it will be better for you. ఎందుకంటే ML కి వెళ్ళిన తర్వాత again if you are not following, right, it will be waste. నా టైం వేస్ట్, మీ టైం వేస్ట్. అక్కడ వచ్చిన తర్వాత సార్ వాట్ ఈస్ దిస్ క్వాంటైల్ అని అడిగితే I cannot go back and again explain. Even if I explain also, it will be time waste for you. Okay, ఎందుకంటే నేను స్టాట్స్ లో ఎక్స్ప్లెయిన్ చేసినట్టు ఎక్స్ప్లెయిన్ చేయలేను. ఓకే, ఆబ్వియస్లీ అప్పుడు మైండ్ సెట్ వేరే ఉంటుంది. ఓకే, సో ఇఫ్ యూ ఆల్రెడీ హ్యావ్ సమ్ బేసిక్ నాలెడ్జ్, ఐ కెన్ బిల్డ్ ఆన్ టాప్ ఆఫ్ దట్. Okay, so that's why I'm saying everything will be a chain reaction over here. So if you just go through this or class gani lekunte make blocks, as I said, go through these blocks wherever any topic over the weekend, excellent blocks unte. For example, meeku towards data science blocks unte. Okay, for example, towards data science lo just go and search box plot. Okay, you will have lots and lots of and very excellent blocks. See, built in anedi kuda excellent untadi. Okay, or if you just say medium, go here, medium, see so many you have analytics vidya. Okay, analytics vidya. Okay, box plot, fine. So see how to create box plot, for example. So everything you have. So if you are not understanding, see, I'm not expert, right? So I know some data science, but I'm not saying I know everything. So in some concepts not teaching meeku ardham gakapoi undochu for some particular concept. I'm not saying don't follow only me, I'm only one person, right? So if you can, these are some excellent guys who are writing, go there. Okay, but na class lo meer chusinapudu at least meeku basic understanding ostadi, what is quantile anedi meeku at least 50% understanding ostadi. From that you will be able to understand these guys in a very much easy way. ఎందుకంటే మీకు ఆల్రెడీ సమ్ ఫౌండేషన్ ఉంది కాబట్టి. ఓకే, సో విత్ దట్ యూ కెన్ ఏదైనా టాపిక్ మీకు ఇఫ్ యూ వాంట్ మోర్ నాలెడ్జ్ ఆర్ సమ్ అదర్ పర్స్పెక్టివ్, ఓకే, యూ కెన్ గో హియర్, యూ విల్ హ్యావ్ అదర్ ఎగ్జాంపుల్స్. Whatever you do, my course or any course, my course will be a very good foundation, very good basics. Okay, so that which is enough for you to go start giving the data science interviews. Okay, so but మీకు ఇక్కడ అర్థం కావట్లేదంటే completely feel free to go to some other blog for that particular topic. Ultimately you should get the knowledge, guys, from me or from anyone. Okay, so do that, have some notes prepared, and it will be very much helpful in your pandas, and pandas will be useful in ML like that. Okay, so yeah, guys, that's from my end, I would say. So if you are good, let's try to meet on Monday. Okay, so as I said, mostly I will not try to skip a class from NumPy, so so that we can complete the course on time. Fine, so on Monday let's start sharp 6 o'clock NumPy. Okay, fine. Are we good, guys? Any more doubts, concerns, anyone?
No, Santosh, fine.
Okay, fine, guys, thank you so much, bye.